Hello, everybody. Okay, so basically, I wanted to go through dynamic masking today, and what specifically dynamic masking is a feature of relational databases. And one way you can mask is basically you remove a particular chunk of the data. You don't let you specifically make sure that that data cannot be viewed. And there is a difference between truncation and masking, right? Because in truncation, you just completely delete that data, while masking, you can actually still unhide or maybe view it again, right? And one thing you would see within dynamic masking is this particular security note. And what does that mean? Okay, so the context of this is basically when we're going through payment card industry audits, one thing that we usually see is a back office application having masked PAN, right? And that's a very common occurrence. But if it's not configured correctly, it can actually leak data. And what does that mean? First line of defense is your app's read user, right? This is your service level account, and this should have the least amount of privileges as possible, right? So let's say we've given it the read user particularly, and now it can see only the masked pan, and the connection string is secured somewhere, right? And now the issue is, let's say somehow we get the access to the password within the connection string. Can we use the mass data to get more information? So what does that mean? Okay, so just going through the SQL manager beforehand, we're just getting the user data, and you can see over here we have some different columns. And over here, the pan column is not masked, and because this is the root user. And when we're executing it through the app reader user, we can see it's a masked, and we're specifically looking at the view, right? And this is some secure way of viewing it. But the only thing over here is when we're enabling back at dynamic masking on pan, that particular part is a bit shady, right? And the reason I'll give you over here, when we're looking at, let's say, a range between 800 8 to 9, right, we get 2. And as soon as we go to and remove, let's say, um over here we remove this and we go to 8, right, what we see is now we can only see one pan. And the whole idea is to substitute all of these numbers to get the particular pan back. And what does that look like? That looks like, first we get all of the masked values. Let's say we got the password from the environment variables. And when we run that program, what it does, it goes through each and every particular number until it gets the entire masked values, right? And as you can see, it did it for all of these within a few seconds. And if this was more complicated or it had more data, it would have been able to access all of this data. So the question is, how do you implement this where this doesn't happen? And over here, I mentioned the particular view mask, right? That means there's a user table as well as a view of that table. And what you can do is you can hard code the masked values. And what would that look like? That would look exactly like this. The only difference would be that it would be a varchar, right? And what that means is that it would have all of these as destructive components. So it's technically truncating the particular values, right? And what would that do? Basically you won't be able to search that. So when we're looking at the back office application, the major thing is that we needed to search the particular values. Now, since it's a masked pan, we don't need the entire value. If we need to search the particular pan values, we can use the first 4 as well as the last 6 characters to figure out the exact PAN number, but we'll never be able to look at what is the actual most sensitive part of the PAN. And this is one way to use this. And if you're potentially giving the user to filter out, then there are no ways to protect this. And then we come to actually protecting the passwords and actually making sure that the access control is specifically as strong as possible.